Hi, today we are going to continue our discussion on geometric sequence, and at this point we're going to use extensively the two equations being used uh, in solving similar problems. So we have a problem here. Write the next three terms of the geometric sequence and find a sub n, which is the last term, and S of n, which is the sum of the geometric sequence. For our solution, we now are going to use the A sub n, no? Which is equal to A sub 1 times the geometric ratio n minus 1. So, what are given here? We know A sub 1, to be equal to 1, the first term, and A sub n we don't know. The geometric ratio, which is equal to, for example here, R sub 4 over 1, which is equal to 4, no? Or 16 over 4, no? So we know the geometric ratio. We're going to substitute this in the formula. No? N is 8, no? 8 terms, no? 8. So just have to substitute this given here. So A sub n is equal to A sub 1, which is 1. And R raised to 8 minus 1, no? So that is equal to 1 times the quantity, R which is 4, raised to 7. So using your calculator, no, 4 raised to 7 is equal to 16,384. Check this out in your calculator. 16,384. So for our next solution, that is S of n, the sum of the geometric sequence from 1 to the 8 terms. No? So that is equal to A sub 1 times the quantity 1 minus R's of n all over 1 minus R. So we have here 1 times the quantity 1 minus R to the 8, no? So this R here, as you know, is 4 raised to 8 over 1 minus 4. So again, using your calculator, we're going to arrive at 21,845. No? So since we know R, which is equal to 4, in computing the next three terms of this sequence here, all we have to do is multiply the A sub 3 by 4 together, A sub 4. So let's try, no? Multiplying A sub 4 is equal to A sub 3, which is 16, times R, no? Which is 4. So that is 16 times 4. So that will be equal to 64. So A sub 5 here, no? Is 64 times 4. So that will be equal to 16 carry 1, 256. And the last term that we're looking for is a sub 6, which is equal to 256 times 4, and that will be equal to 24 carry 2 carry 2, 10, 24. So the next three terms are 64, 256, and 1024. So that's it, no? So we're going to use extensively this formula here, a sub n and n sub n, in solving other equations in geometric sequence. So we go to the second problem, no? We have to erase this, no? So the second problem is about geometric sequence, and so let me erase this for a while. So for our next problem, we have here, find the value of k, find the value of k, no? So that 2k plus 2, so that 2k plus 2, 5k minus 11, and 7k minus 13. And 7k minus 13 will form a geometric sequence. Form a geometric sequence. So for our solution, if these three binomial terms here is to form a geometric sequence, then the ratio of the second term to the first term will be equal to the ratio of the third term to the second term. That is that is 5k minus 11 should be equal, not to, over 2k plus 2 should be equal to 7k minus 13 over 5k minus 11. So what we have to do is to cross multiply these terms here, this equation here. So we have here 5k minus 11, so squared, and that is equal to 7k minus 13 times the quantity 2k plus 2. So we expand this one, so we have here 25 k squared minus 55 110k plus 121 is equal to 14 k squared by using the FOIL method here, plus 14k minus 26, 14k minus 26k minus 26. So we have to combine all the terms here. on one side of the equation. No? So by combining, we have here 25k minus 14k squared is equal to 11k squared. So 110. This one is 26 minus 14 is 12 minus 110. No, that will become equal to 98k. So this one is 26, only 26 here. So 121 plus 26, that will be 147. So this one is 147. That's 147. So as you can see, it will be hard for us to compute the value of k, no? So because of large numbers here. So we'll make use of the quadratic formula. No? Quadratic formula. No? That is k, no, is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. So by using this, we can find the value of k. So we just substitute the value. So this one k is equal to negative b is the second term here. So this one is 98 plus or minus square root. Well, b squared, 98 squared. So negative 98. Quantity squared minus 4, a is equal to 11. And c is equal to 147. So all over 2 times 11. So yeah, so 98 times 98. So 98 times 98. 98 times 98, that is 64, carry 6. 72, 76. Oh, 72 plus 6, 78, carry 7. Well, then 78. 72 again. Carry 7, 81, 88. So this one is 0, 4, 16, 96 of 4. So let's continue. So 98 plus or minus square root, no, of 96 of 4. So this one is 55, 44 times 47. So 44, 147 times 44. So 28 carry 2, 18 carry 1, 5, 28 carry 2, 18 carry 1, 5 again. So 68 carry 1, 14 carry 1, 6, 64, 68. So minus 64, 68 all over 22. So what will happen? So 96 over 4 minus 64, 68, that will become 6. This one time is 3 and 1 and 31, 36. So k, so this is k and this is also k. So 98 plus or minus square root of 31, 36, no, 31, make this clear. 31, 36. So over 22. So using your calculator, we'll arrive at k, which is equal to 7. No? So this is it. This is our answer. So that's all for now. If you want to check the value of this one, we'll see if this equation here or this sequence here will form a geometric sequence. So we just substitute 7. If k is equal to 7, so just substitute, just have to we'll see if we can arrive at the geometric sequence. So 14 plus 2 is 16, and 7, 35 minus 11 is 35 minus 11 is 24. And here 749 minus 13, that is 36. No? Is this a geometric sequence? We'll see, no? So 24 over 16 should be equal to 36 over 24. So just round this off, 1 and 1/2. And this one is also 1 and 1/2. So this is a geometric sequence using k as 7. So that's it, no? Our answer is correct. So next time we'll make another use of the formula here. And please don't forget to subscribe to my YouTube channel. And see you again next time. So, thank you.